Thanks for coming. So when I wrote this talk, I didn't realize that one of the keynotes was going to be about emotions in like work generally, and specifically, obviously, because this is a tech conference, how we might better be aware of and take responsibility for our emotions. But I'd already written this talk, and it's something that's been interesting me for a long time, because I think that emotions and how we relate to code and how we experience the act of development has something really important to tell us. So hopefully, via the media of me telling a bunch of stories about stuff that's happened to me in the past, I can share some of the stuff that I've been worrying about for a long time, around about how we do software, how we feel and think about software, how we react and respond to software, and maybe share some of the explanations which I've come to for the reasons why these things happen, and hopefully convince you that there's something worth looking into and kind of using a similar kind of mechanism to introspect yourselves, and then use that to learn to become better developers, become better pairs, become better team members, etc. But it's not about teams, it's about individuals. So we're going to talk about that. So specifically what I'm going to do, I'm going to tell you to begin with a story of me at Open Spaces Conference, so this Open Spaces Conference, which I was privileged enough to attend multiple times in a small ski resort in Crested Butte in Colorado, where I met and hung out with awesome people who were super smart and just made me feel not very smart at all. But the way I'm going to describe it is going to sound like a horrific experience, because it set me off worrying about how I did development and how I wrote code. I'm then going to tell you 5 more stories, or kind of share 5 more things that worried me about this, because my kind of big worry about am I doing development right then split up into 5 smaller pieces, and emotion came up in lots of those, so I'm going to talk about those. And hopefully by sharing them with you, I'll convince you that you should be equally worried, if not more worried than I was about stuff. And then along the way, I'm going to sprinkle in a little bit of cognitive science and cognitive neuroscience, because that was what my degree is in, not in computer science, which I think pulls all this stuff back together and tells us some really interesting stuff about what is going on when we write code. And so this is the first time I've done this talk. I'd love to get people's feedback. I'd love questions. You don't need to agree with me. If I've made you angry, then maybe that would be good, because then we're experiencing emotion. But if it was a different emotion like happiness, that would be awesome too. So, step 1, though, we need to start off somewhere where we all agree with things. Writing code is awesome. I think a lot of the folks here are here because we just really like writing code. The act of writing code and the feeling that you get from writing code is pretty much unparalleled. So much so that lots of us do it for free, right? Because open source is a lot of people doing what they probably do in their day job, and then, nowadays some of them are paid, but other people go back to their houses and their families and rest of their lives, and we still write code. So to prove this, I've got a few quotes, because it's always good to have some quotes to kind of back up any opinion that I might have. So this is a quote. Does anyone know who said this? It's from the 90s. Does anyone know who this is? Any guesses? So it's Steve Jobs in Triumph of the Nerds. So even Steve Jobs, uber billionaire, kind of Silicon Valley bloke, at one point when he was hanging out with Steve, the other Steve, his name was Steve, who helped co-created the first Macs with him, they got a buzz from hacking on all this kind of stuff, right? But it's not just white Californian billionaires. We've got another quote about the experience and how it feels to code. Does anyone know who said this? Does anybody guess? So that's Ada Lovelace. So technically, the first person, she invented coding, right? Well before there were computers, when she's working with Charles Babbage on the difference engine, she's talking about how it feels to write code. And she's right? And even immediately at this point, there's 2 things I want to pull out. Steve Jobs is talking about how exciting it is and how amazing it is to program some instructions into a computer, and then the computer does what you tell it. Ada Lovelace, meanwhile, possibly slightly more aware of her emotions, is saying, I'm overwhelmed by all of the possibilities. There's so much stuff that's going on. There's a big weight here. It's not just an intellectual activity. And that's what I want to bounce out. That was bad. I should hold on to my thing. So there's one more quote. Does anyone know where this quote comes from? And this is what we're going to take, and we're going to use this quote and kind of build up on it. No pun intended, all the way through. This one's probably the most famous quote, and there's no more quotes after this. Anybody recognize this? So he's from IBM. I think it was IBM. Sorry? Yeah, it is too early in the morning. Sorry, I thought this was going to be later in the afternoon. So yeah, apologies if anyone falls asleep. If it falls asleep, I'll summarize at the end. That's Fred Brooks in the Mythical Man Month, which is another awesome set of writings about software development, software delivery, human beings, all of the pieces of working on software. And what he's talking about is something that I read this years ago, and it stuck with me for a long time, because he's right. It does feel like, and the reason why I think software development feels so good is because we literally are building castles in the air. I started off working in hardware. You can build things in hardware, but it's longer and slower and more physical. It's really, really, really easy in software to build something spectacular and gigantic and detailed and nuanced and subtle and powerful really quickly in software, right? And that feels pretty freaking awesome, right? Maybe you do it for the right reasons, maybe you do it for the wrong reasons, but it feels awesome whichever reason you're doing it for. There's a flip side. It's also really easy to make a complete mess of stuff, right? And so that's an intellectual activity. It's an intellectual activity to build these complicated things. It's an intellectual activity to kind of screw up building these complicated things. But there's the intellectual aspect, but there's also the emotional aspect. We really, really enjoy doing this thing, I think most people. So, that then leads me to the first question. This is the thing that started all the panic that kicked in. How do I know if I'm doing development right? So what I want you to now, I'm going to leave this whole presentation has got very few slides, so I can leave these questions hovering up on the screen to make you panic like I did. I was sitting asking myself this for years. I still don't know if I know the answer. How do you know if you're doing development right? And the thing that kicked it off was I was at this conference, this unconference, and it was self-organizing. So in the afternoons, in the mornings we'd do self-organizing sessions, we'd talk about loads of cool stuff, and I just listened to all these interesting things folks were saying. In the afternoon, people would organize hackathons and stuff, and we would sit with whoever it was doing the hackathon, and we would kind of all contribute and work on some code together. With no goal, just we were doing stuff. The time this comes from, we were sitting in someone's apartment. This person called Joe Sondow was sitting on one sofa. Twitter Bootstrap had just been released, so you can figure out how old this is. I think it's 2004. Twitter Bootstrap had been released, and Joe was basically had his laptop plugged into the TV, and he's working through the Twitter Bootstrap code and writing some code on his, plugging it into his website, because he's trying to figure out whether or not he wants to let Twitter Bootstrap onto his website. So he's a front-end developer. He's really, really smart, really bright. He worked for Netflix. And so he is narrating, he's speaking out loud, he's talking about what he's thinking, what he's doing, why he's doing it. He's writing code, he's live coding as we go. And everyone is thinking this is super awesome and super exciting, and they're all giving him ideas and discussing things and sharing thoughts and opinions. I'm sitting there thinking, this is not how I think about code. This is not how I write code, and this is not how I read code. So I'm having, it's super interesting. Intellectually, I am loving every minute of it. Emotionally, I'm like, this person works for Netflix. I don't work like this at all. So I was like, I'm not sure if this is good. And that question stayed with me, and it still stays with me, because I'm still asking myself this question, because we talk about all the intellectual stuff about code, but I'm not sure we talk about the other pieces. So this question stuck with me. But it was worse than this. So it didn't just stick with one question. Over the years, it split into these 5 questions that I'm going to talk about now. Quick time check, good. First question, and this is one of the things that Joe was doing, was I thinking about code right? Because how are we supposed to think about code? There's not much out there about how to think about code. You get books that tell you about how the syntax works. You get books about architecture. You get books about methodologies and practices and all of these different things. But there's precious little, because I've looked, and there's very little. You get little glimpses every now and then about how you should be thinking about code and what it feels like to think about code. What's the smart way? What's the not so smart way? So for instance, should you think in abstract concepts? Or should you think in the specific concepts of the language? Should you think in the syntax of the code, right? Because I've worked with people, and it feels like they're thinking in the syntax of the language, and then they just it just comes out through their fingers. Other times people are working on this high, when you sit with them, you're like, crikey, that's some complicated thing, and they translate it out. All of which, which I saw with Joe, I was like, how does this work? So we've now got another story which made it even worse, which brings us to our first bit of cognitive science, which is the first life raft that I grab onto, probably not a life raft, more like one of those life ring things. A few years later, we were back at this conference, and Scala was getting big, and so there was an afternoon hackathon, and a bunch of people were trying to figure out how to do Scala. So they picked I think they were trying to write a Sudoku self-solver. So I understand Sudoku, I can solve Sudoku problems. So the problem space was not complicated, and I knew a little bit about functional programming. But it's me and a bunch of very smart people, some of whom will later in this story go on to write books about Scala, which I didn't know at the time. But they're trying to figure out how, and we're all learning Scala. Nobody knows Scala in the room. Some of them are on the doc. Some people are trying to figure out. Some people are typing into IDEs to figure out how stuff works. But all trying to think about how we might break this problem down in a way that we can write it in Scala and then run it, and then we can solve this Sudoku puzzle. And everyone else is there, and they're all contributing, and they're all, like questioning things and asking all the right questions, and it feels like everybody's moving this kind of hackathon forward. Apart from me, my brain is just overflowing, and I'm barely managing to keep up typing along with what's on the screen, and I'm barely understanding what I'm doing as I'm going. So some of that you can attribute to the fact that I hate Scala syntax, and I've now learned years later I hate Scala syntax. But it wasn't just that. My brain felt full. And why did my brain feel full? I was like, we're all trying to solve this problem. Nobody knows the answer to this problem. Everybody's new to Scala. Why is this happening? And so the people whose brains weren't full, or didn't seem to be full, were also experiencing joy, right? They were loving all of this stuff. They were loving the experience of solving this problem. And I was basically kind of struggling under the strain. As someone I used to work with on a very early job said, my buffer overfloweth, right? So there was like just like a computing science metaphor. My buffer was full, and it was just all of this information, didn't know where to go. And so that was not fun. So again, what should have been awesome was basically me just feeling like I was not as good as I could have been at this stuff, and I was failing to learn all the lessons and draw the benefits from this experience. And then years later, based on a book that was recommended to me by someone from this conference, because I was trying to learn maths, because I didn't understand maths, which could have been one of the root causes for not understanding functional programming. They recommended a book to me by Barbara Oxley called, and there's a picture of this at the end, called A Mind for Numbers. And this Mind for Numbers is basically a cognitive science approach to learning how to do maths. There's tons of stuff in it. As someone who's got a psychology degree, it's a bit fluffy and woolly, but there are two concepts in it which are super important, which I realized a few years later are at play underneath what's going on here when you're thinking about code. The first concept is a concept that comes from cognitive psychology and it's been around for a long time. You've probably heard about it. It's still there. It's still kind of part of the cognitive science way of looking at things, and that's working memory. So working memory is a space in your head where you do active thinking tasks, right? So active thinking, which might be remembering a phone number. So if I tell someone a phone number, I nearly said my phone number, that would have been bad. If I tell you a phone number, you can use that to rehearse it over and over in your head. You keep it in your head by doing active things, and then you write it down or you memorize it, and it goes into a different part of your memory. That's working memory. Or you can use it for active thinking, problem-solving tasks. So was the problem that I was experiencing that my working memory was smaller than everyone else's, because we're solving the same problem, we're looking at the same code on the screen, we're going through the same stuff. Did I just have a smaller working memory? No. Working memory is a fixed, give or take, and they've done hundreds of experiments over the time. Working memory is of fixed size. But what I was doing was I was not using my working memory as efficiently as I could have been. So this is the second concept that's in the Oakley book, which I hadn't been aware of, but it's super powerful, and it's how you learn maths, and it's how I believe lots of software development works as well. Barbara Oakley says, what you need to do is you need to form conceptual chunks, because what you manipulate in your working memory are conceptual chunks. There's the building blocks, right? So Brooks was talking about building thought castles. Castles are built out of bricks, right? These bricks could be chunks. Those are the things that you're manipulating in your head, I think. that you're moving around. And so these chunks are made up of other chunks. You can combine a bunch of chunks together to kind of get a higher level chunk, or inside each chunk there's a load of smaller level things. You think about it, like when we do Java, we're not thinking about how to manage memory because we're working at a chunk level where memory allocation and deallocation is done for us. So that's the thing we don't even think about. And then higher level concepts are built up of those. Things like the standard libraries, they're just larger level chunks, so we don't need to worry about all of the other stuff. So what I wasn't doing was I wasn't using chunks as efficiently because I didn't have lots of these conceptual chunks that these people did. Lots of them had done other types of functional programming, so they had the ideas from functional programming, which they didn't have the Scala chunks to map onto, but they did have these concepts, so they could manipulate in this kind of restricted mental space things quite easily. And then they had to use some of their mental space to translate that to Scala, but I didn't even have these big chunks. I had loads of tiny little bricks lying around, and I couldn't keep track of it, and that's where all of this kind of strain was coming from. So that's it. That's what I think is related to thinking about code. So thinking about code is hard, and I think one of the things, if we're going to move on to the next step, sometimes we only talk about the thinking in code bit. That's when we stop, right? So if we did talk about it, we just think about the intellectual activity of writing code, because that's fun. Of thinking about code, but we never talk or talk very little about writing code. So that's the next one. How do we know we're writing code right? So again, I'd watch Joe with his laptop up on the screen with a framework he completely didn't understand. He didn't understand his website, so he understood how he built that, all the CSS and all this kind of stuff. He was a front-end developer, so it was proper posh. But if you sit down and pair with me, and it's a bit of a trial if you ever pair with me, some people here might have not yet paired with me, but if you do, I do not start at the top of a function and work my way down to the bottom of the function. I flap around a lot. Sometimes I'll start at the bottom of a function because I'm like, the one thing I'm pretty certain of is what I know this function needs to return. And when I've figured out what that is, then I can go back and write the signature of the function, but I don't have a name for the function because I haven't got a clue what it's called yet. Then I'll figure out how to get from what's probably been passed into it down to the bottom, and I'll be zooming up and down this class. It's incredibly frustrating for people. I'll then realize it's 3 functions, I'll refactor out 3 different things. I've paired with tons of other people where that is probably happening, but it's happening inside their heads. It's not happening out on the screen. And I think some of this is a reflection of the level of granularity or the level of detail or the amount of work you've done in the thinking phase before it comes out onto the screen. So it's not wrong that I do kind of my loop, my OOAD loop, is shorter. I'm doing less thinking and then flushing it out to buffer, less thinking, flushing it out to buffer. In fact, that's what, if you read the foreword to Kent Beck's TDD by example, Kent says the reason he came up with TDD is because his buffer feels smaller and he feels a strain when he's trying to keep too many things in his head, so he flushes it out, right? And Kent speaks about emotions. One of the few people that you see openly and honestly speaking about how things feel is Kent Beck, which is really interesting. So are we writing code right? I don't, again, not sure if there is, but there's definitely, other things, right? So there's the writing of the code, but that's the mechanical, intellectual, I need to take what's in my head and get it out. What we don't talk about is, or we talk a little bit about, but we just allude to it, is sometimes the writing of the code, when we get into the flow states, and we talk about flow states, which is definitely emotional, because it feels good, right? Us, free climbers, chess, people who play, world-class chess, and a few other people all seem to be able to get into this state occasionally where we completely lose track of time. That isn't just in our heads, that's when it's in our heads and it's coming out onto the screen, onto the system, the flow state, right? So we don't talk about this enough. Other things I don't think we talk about enough, and you notice this a lot when you pair program with people, the environment which I'm in, if I went back in the day when I used to sit next to people to pair, I find it easier when I'm using my tools, maybe for obvious reasons. I find it easier when I'm in my environment. The thinking flows more easily, and it's not just because the keyboard's in a different position, right? Some people spend tons of time on their keyboards and all this kind of stuff, but there must be a reason why, to maybe just get things flowing, etc., to get the mechanical and the movement of your fingers out of the way, because people just want to get that going. So writing code right, maybe I think we need to think about this a bit more. Number 3. So again, software development would probably be more awesome than less awesome if it was thinking about code, which is really good fun, because it's problem solving, and writing code, which is awesome. There's a quote somewhere, which I can't remember, about we spend far more time reading code than we do writing code. So we moan about it and we complain about it. But again, I'm not sure we actually tackle the things that are behind it that kind of, what is going on when we're reading code? Because we're reading code and we're kind of trying to understand what it's doing. But I think there's a bigger, greater piece of detail behind this. Right? I think, we need to kind of engage with this more directly to figure out what exactly is going on when we read code. And so what I think is, because I've spent a lot of time wondering about this, if I have some mental models in my head, right, which are constructed from these chunks, and I'm communicating these chunks out through the medium of the syntax of the language onto the computer, that is the artifact of my thought process on the computer, on the system. So when I read code, I'm kind of trying to reverse the process and go back to move my head to the mental state that the person was in when they wrote the code. That person could be me, right? And it's hard because I sometimes forget what I did before lunch, and I'll come back and I won't remember what I did with code. Or I've frequently been heard to say that what idiot wrote this code, and it was me 3 months ago, and I'd forgotten that I wrote it. And that's still me. So technically, all of the kind of psychological apparatus is probably the same because it's probably still me. But then you get other people writing code, right? And then you get vast arrays of people writing code, and we're all trying to figure out how we can build all of this stuff back up to kind of get to this point where we're getting to this shared mental understanding. So there's a really famous thing, so again, we don't talk about emotions, but we do make jokes about it. So this is a famous cartoon, which you may or may not have seen. And this gives us the clue as to how I think we can start putting some of these pieces together. So it's the famous WTFs per minute measure of code quality. On the left is obviously good code, few WTFs. On the right, bad code. Things that I think aren't commented on enough. The good code still has WTFs, right? So it's still it's still not crystal beautifully super clear. There are versions of this cartoon where there's one here where someone has done some development practice that they advocate for and there's no WTFs. I think that doesn't exist. But there's another elephant in the room, and the elephant in the room is, I think this is written from the perspective of what you're supposed to do is put yourself in the perspective of the person doing the code review, right? So you can laugh at the person who's written bad code because it's, we don't admit we write bad code, or we like, this whole talk's me admitting I write bad code. But luckily I've passed the interview before ThoughtWorks. It's hard for us to sit in the space and go, we write good code, but is it good code for everybody, or is it good code for longer term, or good code for, this overall development practice? So we're sitting there, and I think you read this. I've read this at times where the WTFs are coming from me because I'm like, oh no, who is this idiot? What's this person done, right? So therefore, and then maybe good code is my code because I write good code, right, on the left. But when I read this, there's another thing, there's another fear that's in there because I've done lots of code review, and this is what worries me when I do code review. It worries me that the code is good, but that I'm not smart enough. I can't load up the stuff from the code into my head in a way because I don't have the building blocks to reassemble this stuff in my head. That would mean it was good code, but I'm lacking, not the code. That we don't talk about very much. So I think that's there as well. So we're going to one more step, and then there's this next bit of cognitive psychology where I'm going to start trying to hopefully tie all this stuff together, which is good. We've still got time. So we've still talked a lot. I've talked a little bit about my emotions, but we're not really talking about where the emotions come from. So we could just be having this conversation, although it's me talking quite a lot. We could just be having this conversation about the intellectual act of writing code. If I'm writing my code and there's lots of WTFs per minute, that's a metric, so therefore we could say that I'm just not named my variables clearly enough, or I haven't made my function short enough, or whatever, right? There could be intellectual things that I could do. But it's not just an intellectual task, right? Thinking about code is not just an intellectual task. Writing code is not just an intellectual task. There's joy in actually physically writing code on computers and running that code. And reading code, when you read good code, like there's books called Beautiful Code, right? And sometimes there's a joy in reading code. So where are these emotions coming from? Because I think we're at the point where we can't deny the fact that we do experience emotions when we're writing code. But what we're lacking is an explanation for, and me, because I've got a psychology degree, where are these things coming from, right? Now I get to press the button, which I forgot to press earlier, and there's lots of emotions. So there's obviously a theme of emojis on this things. We need to wait for all the emojis to appear. So we're going to talk about another thing. This story is about Clive, who's kindly sitting at the front to remind me to not lie about the story. I might be glossing over bits about this story. Clive and I were on a project quite a long time ago, but Clive still didn't have hair at that point. And it was big project, inherited code base, Spring code base, super abstract, really flipping complicated. And so we were there, we were all consultants, and we were trying to figure out how to fix bits of it, how to refactor bits of it, how to split bits of it up, how to fix a bunch of problems that were existing in the code base. And so lots of us were basically engaged in tackling various parts of this code base, which was gigantic, like all code bases, and complicated, like all code bases, and written over years, like all code bases. We were trying to figure out how to do something. I can't remember Clive probably tells afterwards what we were trying to do. But Clive had been looking at it for a few days, and then I came over at some point and tried to help. We can find out if I did help. But to help, to pair on the program, not pair program on it, but kind of basically put two minds on it to try and figure out how we might figure out what the root cause of this weird defect was. And it was a weird Spring thing where we ended up, I think we had two Spring contexts were starting up, but they were conflicting with each other. That did happen. So if you ever have two Spring contexts starting up and you can't find one of your beans, even though it should be there, that's because you've got two Spring contexts and you don't know which one you're attaching to with your debugger. So we didn't know that, but we were like, this is weird. But we had some tests, because Clive had written some tests. So we were like, right, okay, we think this is what the problem is. We'd read a bunch of code which we hadn't written. Clive had taken an existing test, had changed a small part of that existing test with some form of contribution. And we were about to run that test, and we were like, right, doing this, we'll take this test, which is working, it will break it, and it will break it because of this. And Clive then said, when we were running the test, because the test didn't run very fast, I remember that Clive said, I think this will fail, and it will fail with a 1 instead of a 0. Could have been a different value. I thought it would fail with a null. We probably went for lunch. We came back. We looked at what happened. The test, what we'd generally predicted had happened. So the test had run, the test had failed in this scenario, and it had failed, as Clive had suggested, with a 1, not a null. So Clive was super happy, because Clive had spent ages trying to figure out this blooming thing. I was like pretty chuffed that we'd fixed it, but inside there was a bit of me, and I was like, but wait a second, how come we're like, the fact that I thought it would be a null and it had failed meant that there was still something that wasn't right about what I was trying to understand. Whereas Clive was like, oh, maybe we're on to have got a bit of a toehold on this problem, right? Now we can start digging into it and stuff. And so what I want to point out is, it was the same code base, neither of us had written it, Clive had looked at it a bit longer. We sat next door to each other, so it wasn't like I was in my beautiful, glorious, fully soundproofed office at home, and Clive, meanwhile, was working in the corridor of his house with the kids distracting him and stuff. We were in the same environment with the same pieces of kit on the same code base. Everything was the same, and yet my emotional experience of this thing was different from Clive's emotional experience. So maybe it's kind of obvious why they had a different experience, but I don't want to get to the kind of the human being rational explanation. What I want to do is get to the kind of what's a psychological way of looking at this. And so this is our second bit of psychology. There's a currently running, really, really interesting set of investigations at the moment in cognitive neuroscience. And I got put onto this by another person who went to this conference, Julie Pitt, who needs to get a shout out. Julie put me onto this thing, and it's really, really, really interestingly summarized in this book called The Predictive Mind by Jacob Howie. So, if we go to the next slide quickly, I think I've gone to sleep. So far, when I've talked about things, it feels like we've talked about this. You do some thinking, you do some typing, and you do some reading. Right? But I was trying really hard not to give the game away, because it's not really like this. It's like this, right? We talk about feedback loops all the time in software development. We never talk about the feedback loop that's going on inside the human being's head. Or we talk about the outside, the external bits of it. This thing, The Predictive Mind, the book by Jacob Howie, again, there's a picture at the end, you can see it, takes this cognitive, basically summarizes this whole kind of, this thread in cognitive neuroscience at the moment. And what this thread in cognitive neuroscience says, our minds, Well, what we think of with our minds, right, might be a side effect. We might not really be conscious, blah, blah, blah. Existential crisis number 2. But what we have in our heads is a predictive model of the outside world for everything, like where the things are, right? The fact that Sarah's sitting over there. That's, my mind is doing that, right? I've got a predictive model of the outside world. I use that predictive model to guide how I interact with the world. So like I know that if I don't hold on to this again and move my hand, this will go flying. Our senses then give us information based on what is actually perceived, and our perception, right? The raw sense data comes in, and what we perceive is the meeting of what our minds predict mapped onto what our senses actually sense. So I'll say that again. We have models in our heads, which are predictive models. They basically hypothesize what the world is like. Then we use that to act. So like if I move, I think some people will move more because they're closer to me. People further away will not move closer to me. And then the sense things move stuff. That's how optical illusions work. Tons of stuff. Read the book. It's amazing. So they're like, and they do this at a neural level. They've got models that prove this, right? So this isn't like some weird social psychology thing. It's hardcore. People are building neural nets that do this stuff. So that's how everything works. When we write code, and this isn't in the book, we're making our mental castles. We're constructing predictions of how things are going to work in our heads, then we write them on the computer, and then we run them, and either we watch the output of the program, or we see the output of the tests or whatever, or the compiler, right? We get the little red squiggly line, so right, if that doesn't work, that's bad syntax. That's a loop. We are mapping on what we think we expect in our heads onto what we perceive. So that's one key thing. That's still not emotion. What they say is the difference is experienced at a basic level as surprise. They call it surprisal because they're cognitive neuroscience, but it's surprise. We feel surprised. But surprise is free energy, and it's like free energy, not in some weird sense, but free energy in a kind of neural excitement thing. So this has to be dissipated. The way we dissipate this, they hypothesize, and it makes a lot of sense to me, is emotions get involved. So emotions explain away things and kind of get rid of this energy. It's how we deal with stuff. It's how we deal with the happy things and how we deal with the sad things. Because we can't have this mismatch in our heads. It doesn't sit. Because the world we're in versus what we're predicting is different, so we need to somehow make that fit and work. So in code, what does it come down to? In code, it comes down to, I think, 5 different things that kind of give rise to the emotions that we experience. So the mismatches are these 5 things. Number 1, and we can doubt various bits of the process. Number 1, we can doubt our typing ability. Frequent go-to for me. So I still think the picture of what I think I'm trying to build in my head is correct as a solution to the problem. I think that what I've seen is correct, that the program didn't run. What I realize is my hands are unable to type semicolons in the right place. Or I've forgotten that in Python you need to have 4 spaces, not 2, or something annoying, right? So that can be a reason why there's some difference, right? So that's an easy one, right? Sometimes you're just like, oh, I'm an idiot, and then you just can think, but that's an emotion, right? You're like, oh, I'm an idiot. Next one. We can still think everything's correct, including the fact that we typed it right, but we realize that the model we've got in our heads to solve the problem, we're like, oh, okay, the thing we've got in our heads to solve the Sudoku problem doesn't work because we've misunderstood the Sudoku problem. So the code's right that we've perceived, we wrote it right based on what's in our heads, and the thing in our heads is coherent, but it's not right for the problem. Next one, there's something wrong in our heads. So now we're moving into, when we start dealing with this, we are having to start dealing with and acknowledging and wrestling with the fact that the mental models we have in our heads, the mental castles we have in our heads, are not as clear or precise or detailed or correct as we think they are. That's getting harder to deal with, right? That's like, I've put a lot of effort into constructing this thing. Clive spent a lot of flipping time trying to get his head around this gigantic Spring code base, right? We didn't know that you could start 2 Spring contexts in parallel. We found that you could, and then all weird manner stuff goes wrong. But we'd assumed the Spring context is like a place where you put everything, right? This single, one version of everything, because it's the single Spring context. We hadn't got a complete understanding of Spring and how Spring works, including all the bugs, all the defects, all the weird side effects. And frequently we don't trip up on these things, but when we do, that's our mental model. Our mental model is not detailed enough of how the Java libraries work or how Scala syntax works or something. Sorry, that's number 4 as well. The mental models that we constructed is 3. The underlying ones, we're not aware of every single weird side case of how Java works, or Ruby works, or Python works, or a library works, or Spring works, right? When we're in control of all of this stuff, we have all of those mental models, all of the levels of chunks. But who has that, right? Nobody has that. We're just lucky we don't trip into them. And number 4, this is the most, and I think this is one where like you see like people going crazy and throwing laptops out the window. We can doubt our perception. We're like, I typed this correctly, and I've spent days, you know the classic, I finally found out what was wrong. We are seeing the missing semicolon, but we are not perceiving the missing semicolon. So we go around doubting every other single thing until we realize that we mistyped the semicolon and we find it, right? That is another massive, gigantic source of frustration, anger, desperation, inability to sleep, inability to unload this from our heads, all that kind of stuff. That one's really flipping hard. And I think being aware of these things, this is the thing where I've got to. Being aware of these things, and now when I'm like debugging, I'm like, right, I kind of go through these separate things to figure out where it might be. Even though it's super unpalatable, I'm like, am I really? Because you do. Sometimes someone will come along, and I think that's what I thought I might be doing with Clive. Surely Clive's missed something really obvious. I'll come along and fix it. That wasn't what it was. But sometimes someone comes along, or you do rubber ducking, right? You explain what's going on. So someone without having all of this emotional investment in the fact that it can't possibly be the fact that I'm just not seeing it properly. We have these techniques. I think that's why this works. So, question number 5. I was like, this is awesome, but it still doesn't tell us about the varieties of religious experience, varieties of development experience. But I think it does, because obviously, we're human beings, we've got tons of stuff going on, right? So there's variety and difference all over what we're doing all the time. There's variety in our education, variety in our background, variety in our home environment or our work environment, variety in the levels of stress that we've got. All of the stuff that makes us be able to bring more or less of ourselves to this act of software development. But there's 2 things that aren't variable, I think, and those 2 things are working memory and the fact that we use chunks. That's there. The quality of our chunks can vary, and like how efficiently we use them and how we build them up and how we manipulate them. We can practice that, and that's why you get katas and all these things to build up the mental muscles. But that is a proven psychological thing. Everybody has it to a greater or lesser extent, within a very small degree of freedom. The other thing is, like all good scientific theories, until presented with a better example, I think the predictive mind loop mapped onto what we do with software development, I think that and the fact that we're constantly, these 3 acts and we're mapping back on, we're mapping around. We might start at any point in the circle, but we're constantly doing this circle. That is also happening to every single one of us. We might have a less good loop. We might be optimizing for less bits of it. Like I said, I optimize for like flushing my buffer to code as much as possible, which is why I love TDD. Other people hate TDD because they don't like trying to have to just think about the test and then go around the loop and then think about the implementation and then go around the loop and think about the refactoring. They'd rather think about it all at once. That's why I think it's hard, why people don't like TDD. Because that's, I'm trying to tell them to do something that they don't like doing. It's not part of their conceptual inner loop. So that tells about the variety. That's where I think the variety comes from. And then the final variety is we're presented with this kind of surprisal, this basic thing which we can then choose to do with as we will. How we react and respond to that will just based on how we are psychologically at the time, right? Some people love a challenge and they love a really gnarly bug, so they go in and they love doing this stuff, so they go and find those bugs. Other people I just want to do the good stuff and just want to flow. And all the things in between, right? That's where all this stuff comes from. So, to now maybe, hopefully, send everyone off in a slightly worrying tangent. So at the start I said, how might I know if I'm doing development right? What I want to do is ask everybody, and you might completely disagree with everything I've said, in which case that's fine, but I spent a long time thinking about this. How might you know if you're doing development right? So if you're intrigued by this and you want to go on this mini existential crisis journey, like maybe with a slight, because for a long time, until a year ago, I really hadn't figured out what this meant and I was just worried about it. How might you go on this journey? So key things are, especially number one, just because development, as another ex-colleague would remind me, is a team sport. But start focusing on yourself, right? Because obviously if we bring in social aspects, it gets more complicated. So step one, if you focus on yourself and just focus, like acknowledge the fact that there's this cycle, right? And acknowledge the fact, test out the fact that there's this kind of working memory buffer and you're using chunks in it and you're manipulating those chunks, and just get used to the fact that these things might be there and be aware of them. And kind of start watching out for surprisal, because it's interesting. Since I've kind of stole this thing from the predictive mind, I sit on loads of like Slack channels at this conference. It's a really good Slack channel. Slack channel at the conference, Slack, GChat channels at work. And if you look for the word, people basically saying, I was surprised, I thought this would happen and this happened instead. The surprise thing is popping up all over the place. People are like, that is a real, if you like cataloged all the time we get surprised by software development, that's a hook. That's why it convinced me that this was real, right? And people are constantly going, but I thought Java worked like this. Well, it does, but apart from this little thing there in Java 1.8 where it does a weird thing because there's a weird library which we can't fix because it will break something in Java 1.4. That's there, so watch out for that. That can only get you so far because I think we are comfortable. Lots of us have gone to this because we're comfortable in the intellectual space, right? It's challenging, but also it's good fun. So that might be hard. So if you can't lock in because you keep getting sucked into the loop and the act, like unconsciously the act of writing software development, either do something which you hate, which is for lots of people TDD, which I still love, but do TDD because it will force you to do the steps, or pair program, which is terrifying the first few times you do pair programming, because the thing in pair programming is you are trying together as a pair, trying to come up with this shared mental model. So you're forcing this thing outside of one person's head into two people's heads at the very start, from the very beginning. That's ludicrously hard. Plus you might not even like each other, right? Or you get on great with each other, but one of your style is one way, another one of your style is another way, or today you've had, you're trying to match up as much as possible. And that's why it's super powerful, because when you match up, it's ludicrously powerful, because you're getting like double reinforcement on all of these things and it magnifies. That's why pair programming is awesome, I think. It's also why it's hard. If it's not gelling, right, it's like you're trying to put two gears together and it's not working. That's why it's hard, I think. So if you try and do that. I think that's it. Yes. So that's what I reckon, what I would love people to do. I would love feedback on this talk. This is the first time I've given this talk. Hopefully it was clear. In my head it feels like it was clear, but that's like my prediction of what's going to happen. Maybe it made no sense at all. Those are the books. They're really good. But yeah, what I just really would really love to hear is, like, I think, like I say, I think the way into this is emotion is not like a weird side effect. Emotion is a clear signal into all of these things, right? If you're feeling something, acknowledging that and using that as a tool, and this is what I said at the start, right? It's picking up the challenge from Lindsay on the keynote yesterday. This isn't just a thing that you should look after because it's, if you're angry or frustrated, you should acknowledge it because it's pretty bad to kind of just push it down. I think it's telling us how to be better developers. I think it's telling us when we're not happy with our IDEs, when we're not happy with our work environment, when we're not happy with the code we're working on, et cetera, et cetera. I think if we get that, we can learn better, we can do better tools, we can build better frameworks. Like surprise, if you're building a framework to minimize surprise and maximize joy, that's got to be good, right? I'm going to love building with that framework. So that's my call to action. And I've now got 7 minutes for questions, and I couldn't get my phone to work, so I don't know if there's any on the app. Or maybe nobody's got any questions. Go. Tristan, hello. I think so. So, caveat. So, Kristen's question was, what's the best way to share these emotions, especially when you're pairing? Because we're both authors, we pair all the time, because it's part of the cult that you have to join. I think I've been lucky. So, I don't write as much code as I used to because I've got promoted one step too far by accident. Sorry, that's a privilege that I got promoted one step too far by accident. But I don't get to write. I get to help people like Tristan have the environment to write good code, which is massively awesome. But I do get to write code. And on my last gig, we got to write some Power BI code, myself and the other person who was too senior to be doing this kind of stuff. We were lucky. We had a really good relationship. So we could just admit the fact that dates logic in Power BI is horrific, and we were both idiots, and we both had 40 plus years of experience of trying to write code, and it shouldn't be this hard, and it was a nightmare. But we were talking about, and lots of this came together while I was working with Pete, so shout out to Pete. Because I'd be like, Dad, what? Sorry, how does this stuff? And then he would be like, oh, that wasn't surprising to me. And then he would explain to me why he didn't think that was surprising. And I would go, oh, right, I had a completely different concept of this thing. So it had to be a bit safe, because I had to basically go, because they were paying me to be there for the stuff that I knew. So for me to then go, I really don't know how this stuff works, that could be a bit risky. Or just emotionally, risky to just kind of say, I'm a bit stuck on this. But the fact that we could do that, we could iterate, and two old idiots built a 4 key metrics, come and see the talk when I write that talk, 4 key metrics dashboard in Power BI in our spare time, and it was good fun. It was flipping hard work, but it was good fun. Could have been a flipping nightmare. But we were talking about this kind of stuff. So yeah, I think ideally, if we can, and then we're talking about our emotions, right? We're talking about when we're frustrated. We're taking breaks because we need to take breaks, etc., etc. We're writing code because it's minimizing surprise and things. Any other questions? I'm assuming there's none on the... Go.
Do you think that you learn how to deal with kind of emotions related to the writing code with the experience? You know better because, for example, okay, first of all, the coding is complicated. Yes?
Yeah.
You have to have that special mental model to understand. Yes. Then, from experience, okay, I'm struggling now, but finally I will find the solution. Yes?
Mm-hmm.
So a lot is coming on from experience. As a junior, you will always say, okay, this is hard, I'm stupid,
Yeah.
this kind of emotions, but then you just realize at some point, okay, that's how it is.
Yeah. So I think you're right. So the question is kind of how does being aware of and being aware of the journey on your awareness of your emotions, but also the things that is causing the emotions, like how much you know and what your levels of experience are, how much that impacts things, right? I guess. And you kind of answered your own question as well. So I completely agree. It's so I love learning. So I like going into places where I haven't got a flipping clue. But I think that's got me really comfortable with admitting to myself that I really haven't got a clue what's going on. And I enjoy it. And then so Pete and I, both of us didn't have a clue what was going on. So we were enjoying not having, not understanding and discovering things and Googling every second line of code that we wrote, maybe every line of code we wrote. All of that cool stuff. And trying to figure stuff out. And then we could bring that into other things that we were working on. And we were also, when we were aware of it as leaders, we were trying to we were trying to celebrate and make it clear when someone discovered something that they'd learned, we were making, and it goes to all of the cultural stuff, right? When a team struggled and failed, we were trying to celebrate that as much as everything else, because otherwise it would associate that with negative feelings, but it should be with positive feelings, right? We've learned a bunch of stuff. We've learned that we definitely shouldn't have chosen Kafka. We didn't choose Kafka, but you know what I mean? Pick something which could be super complicated and might not give you what you want. We wanted to celebrate that because we wanted it to be fun. We wanted people to enjoy themselves. And we wanted people to do stuff. And I think it's interesting. It's interesting to me that things that take off seem to have good libraries or good languages or good tools, right? So the tools are, again, important. But also, I think, good communities. I think if you can go somewhere and put your hand up and say, I really don't understand this, and the barrier to having an emotion to be vulnerable is low, I think that's super key. Be welcoming and help people learn and stuff. Because otherwise it's it's the problem with lots of functional programming. There's this thing where you're you can't do FP unless you understand maths, which is why I read the book. So now I kind of understand math. But I didn't, and they were well, come back later when you've understood maths. And that feels bad, because functional programming's got so many cool things in it. And this isn't all functional communities, but it's some functional communities. And that's it's not great. But I think it could be. I think we could build. I want to build functional stuff. I did a talk yesterday about DDD. DDD is inherently functional when you read parts of the book. But it doesn't say it just is. So, any other? I've got 1 minute left. Go. Is there less than anyone else? No.
Does TDD actually build in emotion into the process? You start off with
Yeah.
your worst possible
Yeah. TDD is, because yes, TDD and like a please, because the reason I thought there must be, after I had the panic, I think a week later I read the Ken Beck book, which should be up here, which is Test Room Development by Example. The foreword to that book, he talks about his fear, his discomfort. He talks about the fact that he feels uncomfortable when he writes a test and all this kind of stuff. There are patterns in that book where he explicitly calls out, you have to run the test to see the red because you need to feel the discomfort that there's something that's not implemented. You don't just go, I've written a failing test, now I'm going to implement it. You run it and see the red because you're supposed to feel discomfort. He talks about if you've got tons of stuff in your head, write all of them down apart from one thing and you implement one thing and you offload all the other stuff. Right? It's what's in your mental, it should have been obvious if I'd read the book a bit more closely. He's like, you're now going to do just enough to implement this test to make it pass. You will feel ugly and like a lesser class of developer because you haven't built this beautiful thing. Don't worry, that's step 3 when you're going to do refactoring. It's super built into it, right? All of that stuff. Kent was on it. The XP people basically had it figured out, and we've just been rediscovering what the XP people figured out. How many years ago it was. But yeah. Cheers, folks. If you have any, I'll be around for the rest of today until I need to disappear for a parents' evening. So if anybody's got any comments or feedback, and that's my Twitter handle, which is not very memorable, AL94781, which is, because I got on Twitter very early before it was a big thing. So yeah, if you've got any comments, please just share them. It'd be really cool to hear. Thanks, everybody.